Welcome back. This is Mr. Hassan's Maths channel, and I'm now answering a question from one of the old Solomon papers for C4. This is Solomon F, which is in my end of topic worksheet, binomial expansion, question number 5 from my P4 collection of questions. And this question here is about binomial expansion. And part A starts off simply with telling us to show that 1 and 1 over 24 to the power of negative a half is equal to k root 6, where k is rational. Okay, so you're going to show how this becomes something where you end up with a fraction times root 6. So what we can do here is we can rewrite this first as an improper fraction. So this is 1 and 1 over 24 become, you multiply the, the numbers here. So 24 times 1 plus 1, that gives you 25 over 24, and that's raised to the power of negative a half. You can think of it as this is 24 over 4 plus 1 over 24, gives you 25 over 24. And then the negative power means we're going to write this as its reciprocal. So you have the numerator and denominator switch places, and it goes to the power of positive a half, which means basically the square root of all of 24 over 25, which means you can take the square root separately of the numerator and the denominator. So if I take the square root of the numerator, I have basically a product of two numbers. One of them is a perfect square, which is 4 times 6. So you're going to have 2 root 6, and the square root of 25 is 5. So we can see here k root 6 where k is rational. So we can therefore say that 1 and 24 over, 1 and 1 over 24 to the power of negative a half is the same as 2/5 root 6. So we can say k is equal to 2/5. Okay, so there's the answer to this question. We've shown that it's equal to k root 6. So here's our answer here. And okay, so when they say show something, it's always best to put your steps, very clearly and, logically. So everything's written in detail here. So there's part A. Obviously, it seems like we're going to be using that later on in the question. So now we're going to move on to part B, and it says in part B, expand this bracket 1 plus a half x to the power of negative a half, where the modulus of x is less than 2, in ascending powers of x up to and including the term in x cubed. Okay, so when we have something like this, we cannot use the NCR method anymore like we could in P2 or C2, because the power is now negative. Even if it wasn't negative and just fractional as well, we couldn't use it. We can use the NCR method when we have positive integers powers. So now what we're going to do is we're going to use that formula that we know, which is given in the formula sheet, which I'm just going to copy out here. So you have 1 plus x to the power of n equals 1 plus nx plus n times n minus 1 over 2 factorial times x squared, okay, plus n times n minus 1 times n minus 2 over 3 factorial times x cubed. This is like the formula that they have in the formula sheet, where the n stands for the power and the x stands for whatever term is here, including its sign. All right, so here we have 1 plus a half x, to the power of negative a half equals. So you have 1. And by the way, this formula only works if there's a 1 in the place of, in this position here. It has to be a 1 here. Okay, if it's not a 1 here, we have to make it a 1. In this case, we don't have to worry about that because it is a 1. That's fine. If it isn't, we would have to make it a 1 by using some sort of like factorizing kind of process, which you'll see in some of the videos where it wasn't a 1. But in this case, we don't have to worry about that. We can just go ahead and use this formula straight away. So you have 1 plus n being the power. So you have negative a half times x being the term in this place, including its sign, so it's positive, so there's going to be a half x. All right, that's the x term. We've got to go up to x cubed, so we've got 2 more terms to go. So we have plus negative a half times, we're going to have negative 3 over 2. Take away 1 from that. Minus 1 minus a half minus 1 is minus a half minus 2 over 2, which is minus 3 over 2, over 2 factorial, which is 2 times 1, times, and whatever's in here, half x but then squared. And then the last term will be negative a half times negative 3 over 2 times negative 5 over 2, taking away another 1 or another 2 over 2, divided by 3 factorial, which is 3 times 2. And then we have a half x to the power of 3. And that's as far as we have to go. So let's simplify what we got here. We got 1. This is going to be negative. So our minus a quarter x. And this will give you a positive term because you have a negative times a negative. So it'll be positive. And we're going to have 3 over 8. So I'll put 3 over 8. And then I'm going to square this. That's going to give me 1 over 4x squared. Okay, it's always good to multiply these separately from that so that you don't make the mistake of multiplying this before you square it, before you raise it to the power. And here you're going to have a negative times a negative times a negative, which is going to be negative. So it's going to be a negative term. And let me just cancel out this 3 with this 3. That's supposed to be a 5 there. Let me write it a bit clearer. That's minus 5 over 2. Okay, so we've got a negative term. That 3 is cancelled with this 3. So we've got 5 over 2, 4, 8, 16. 5 over 16 times. And we have 1 over 2 half x cubed, which is 1 over 8 x raised to the power of 3 plus ... We finish there. Okay, so now we can simplify everything. We have 1 minus a quarter x plus 3 over 32x squared minus, and now we've got to do 5 over 16 times 8, that's 80. 80 plus 48, that's 128 x cubed, and there is our expansion. Okay, so we've expanded this up to and including the term in x cubed, and we've simplified each term. So there's part A and part B done, and now for part C. So it says use your answers to your answer to part B, which I've written down over here, with x equals 1 over 12 to find an approximate value for root 6. Give your answer to 5 decimal places. Okay, so we got to take x equals 1 over 12, and let's put that into this. If we put that into here, we have 1 plus a half x to the power of negative a half will become 1 plus a half times 1 over 12 to the power of negative a half, which gives us 1 plus 1 over 24 to the power of negative half, which is exactly what we had right in the beginning, the first part of the question. This was basically 1 and 1 over 24 to the power of negative a half. 1 and 1 over 24 to the power of negative a half, which we said became 2/5 root 6. Okay, so what we've done is we can replace the x in this, and you get 2/5 root 6. And we know the expansion of this is going to be 1 minus. Now I can put x, if I put x equals 1/12 in here, I'm going to put x equals 1/12 in here as well. So you have a quarter times 1 over 12 plus 3 over 32 times 1 over 12 squared minus 5 over 128 times 1 over 12 cubed. Okay, so let's work out what that gives us. So we have 1 minus a quarter times, we have here, 1 over 12. And then we're going to have, close up afterwards. Then we're going to have plus, we're going to have 3 over 32. 3 over 32 times, we're going to have 1 over 12. That will be squared. And finally, minus, I'll have 5 over 128 times 1 over 12 cubed. Okay, so that will give us all of this, which gives us 0.979 795. So we have 2/3, sorry, 2/5 of root 6 is equal to, so we want the answer to be 5 decimal places at the end. So I'm going to write this to at least 6 or 7 decimal places in the beginning. So 0.979795. 0.979795. 51010, it goes on like that. So now we want to find an approximate value for root 6. So we're going to take root 6 and we're going to multiply it by 5. We're going to multiply this side by, we're going to multiply both sides by 5 over 2. So 2/5 root 6 multiplied by 5 over 2 will give you this side also multiplied by 5 over 2. And that should give us an approximate value now for our root 6. So we're going to just now take this and multiply the answer by 5 over 2. And that gives us 2.449487. So we can say root 6 is equal to, so root 6 is equal to, we can say 2.449487. 2.449487. 4877 goes on like that. So we want this rounded to 5 decimal places. So we have 1, 2, 3, 4, 5. So we can say root 6 therefore is equal to 2.44949 to 5 decimal places as required. Okay, so there's the answer to this question part C. So we're using basically the expansion with x equals 1 over 12. X equals 1 over 12. I should say 1/12 there. All right, and we've put it into this bracket, which gave us exactly what we had in part A, to rewrite this in terms of root 6, which is helps us in this question. And also we put it into our expansion of the bracket up to what we got up to in x cubed, and that gives us an approximate value. It's approximate value of root 6. So what we can do to check our answer actually is we can compare our answer to actually what root 6 gives us, okay, as a decimal, which is 2.44949 to 5 decimal places. It gives you exactly the same thing actually, right? It starts getting different after that. But if you round this to 5 decimal places, 1, 2, 3, 4, 5, it gives you 44949. 44949 gives you exactly the same thing. So it's a good approximation there, very close. And the reason why it's a good approximation is because x equals 1/12 is a valid value. That's something you can put into here, and the expansion is valid because the expansion is valid as they told us, and as we should be able to calculate for ourselves. If the modulus of whatever's in here, if the modulus of a half x is less than 1, in which case, in this case, the modulus of x is less than 2. They told us that, so that's fine, but sometimes they ask you to find the value of x for which this is a valid expansion, and it's whenever the modulus of this thing here, when it says a 1 over there, the thing that goes inside our formula in the place where it gets squared and cubed and stuff, if the modulus of that thing is less than 1, then it's a valid expansion. So in this case, a half x, the modulus of half x is less than 1, that means the modulus of x is less than 2. Okay, so that answers part C and completes this question. I hope that was clear. Thank you for watching. Other questions from this particular paper, Solomon F of P4, old C4, can be found in the playlist that will be showing over here. And other questions from the topic of, or from this end of topic worksheet on binomial expansion, you can find in the playlist over here. Any other questions from P4 binomial expansion that I've answered, you'll also find in the playlist over here, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.